Hello and welcome to the AI Research Roundup. I'm your host Alex, and today we are diving into some interesting AI research. We'll be looking at a paper titled Tau Bench, a benchmark for tool-agent user interaction in real-world domains, which was just published on June 17, 2024. So, the main idea here is that current benchmarks don't really test how well AI agents interact with actual users or follow specific rules, things that are super important for real-world use. This paper introduces Tau Bench to fill that gap, simulating conversations and checking if the agent achieves the goal correctly. Interestingly, they found even top models like GPT-4o succeed less than half the time. Okay, and yeah, if you're interested in digging into this benchmark yourself, the authors have actually released the code and data publicly. This image shows their GitHub repository for Tau Bench. You can see the file structure on the left and parts of the README file on the right. This README includes a leaderboard showing how different models performed, using those Pascal metrics, along with detailed instructions on how to set up and run the benchmark, test different agent strategies, and even use different user simulators. They've also included historical trajectories and an error identification tool, so it's quite comprehensive. Alright, so this figure really helps visualize the Tau Bench setup. On the left, part A shows the basic components. You have the agent interacting with a set of tools, like database APIs, and also interacting with a simulated user. The agent gets a domain policy. Think of it as a rule book, and the user gets an initial instruction to guide the conversation. Then on the right, Part B gives a concrete example from the Tau airline domain. We see a user asking to change a flight. The agent checks the details using a tool, finds out the policy doesn't allow changing that type of ticket, explains this to the user, proposes canceling and rebooking instead, and then acts on the user's confirmation. This really shows that back and forth, and the need for the agent to follow specific rules while talking to the user, which is exactly what Tau Bench is designed to test. Okay, so building on that general setup, this figure gives us a closer look at the specific parts for the Tau retail domain. We can see an example of what the underlying database looks like, showing an order entry with item details. Then, it shows the actual Python API tools the agent uses, like functions for returning or exchanging items. It also gives snippets of the domain policy, those rules the agent has to follow, like only exchanging delivered orders. Finally, it shows a user instruction, which includes the ground truth actions and outputs used for evaluation. But remember, the agent doesn't see this ground truth. Right, and this table gives us a quick statistical comparison of those two domains we've been talking about, Tau Retail and Tau Airline. You can see both use databases with 500 users, but Tau Airline has more complex entries like flights and double the number of reservations compared to orders in retail. Interestingly, the number of API tools is pretty similar for both, around 13 to 15 total. However, Tau Retail has more than twice the number of evaluation tasks, 115 compared to 50 for airline. This suggests the airline domain's difficulty might come more from its complex policies rather than just the scale of the database or number of tasks. Okay, so now that we have a sense of the domains, let's look at how well current models actually perform on them. This figure shows results specifically for the Tau Retail domain. The top part, figure 3, compares the average success rate, that's the PAS-1 score, for different models like GPT-4o and GPT-4 Turbo, using different methods like function calling, react, and act only. You can see GPT-4o using function calling does best, but still only succeeds about 60% of the time. Then the bottom part, figure 4, shows how performance changes over multiple trials, represented by K. The solid lines show the PAS-K score, which is the chance the agent succeeds on all K trials. Notice how steeply these lines drop, especially for GPT-4o, meaning even if it succeeds once, it's not very consistent across multiple tries. This really highlights the reliability challenge Tau Bench exposes. Okay, so we saw that even the best model, GPT-4o, fails quite a bit on Tau Retail, around 40% of the time in the first trial. This figure helps us understand why those failures happen It breaks down those 36 failed runs for GPT-4o using function calling. You can see the biggest reason, about a third of the failures, is providing the wrong argument to a tool. Then, making a wrong decision accounts for a quarter of the errors, and giving the user wrong info is another 22%. Finally, almost 20% involved only partially resolving the user's request. Okay, so building on those failure reasons, this figure gives us another angle on what makes tasks difficult, specifically looking at the number of times the agent needs to actually change the database using a write API. This chart shows the success rate for GPT-4 Turbo and GPT-3.5 Turbo on the retail tasks, grouped by how many write actions were required. You can clearly see a trend as the number of required write actions increases from 0 up to 4. The success rate for both models goes down quite a bit. So, tasks that involve more steps changing the database are definitely harder. Alright, so we've seen that things like the number of database changes make tasks harder. This table explores another factor, the importance of those domain policies we talked about earlier. It shows what happens to the pass 1 success rate for GPT-4o and GPT-3.5 when the policy rules are not given to the agent. You can see performance drops for both models in both domains. But look at GPT-4o on Tau Airline. The success rate plummets from 33% down to just 10% without the policy. This really underscores how critical following those specific rules is, especially in domains with more complex procedures like the airline one. So, it's clear that following specific rules in handling complexity are big hurdles. Well, this Tau bench paper really highlights that even top models still struggle with reliably using tools in realistic scenarios, especially when tasks involve multiple steps or strict policies. Benchmarks like this are super important, though. They give us a clear picture of these challenges and help guide research towards building more capable AI agents. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.